So, hi. Don't worry, I'm not trying to sell you crypto coins today. Also, I hope nobody here just scanned a random QR code at a security conference. So, don't worry, it will be back. You can make your bad decisions later as well. Instead, I'm going to talk to you about our talk, Committed to Trust. This talk is based on our publication, Committed to Trust, a qualitative study on security and trust in open source software projects. And this work would not have been possible with all of these awesome people, including Woehler, Klemmer, Marcel, Fourné, Yasemin, Acar, and Sascha Fahl, who are in fact all here at IEEE and are sitting right in front there. And of course, this wouldn't have been possible without all of our participants who generously donated their valuable time for our research. Somewhat less awesome, but still relevant to this talk is this person. This is me. My name is Dominik Wermke, and I will be your presenter for this talk. So there, the QR code is back. You can now make bad decisions if you want. You can find there all supplemental information for this talk and for the publication, as well as the slides if you want to follow along on your own device. All right, let's get started. First, I want to convince you of something, that is why you should care about open source and related to that open source software security. Here's a slide of open source software logos. You are probably aware of some of those logos and maybe even use the tools from time to time. But open source probably has permeated your life more than you are aware of. Open source code appears as foundation, glue, or during the build process in many software projects. Whether as low-level system driver in operating systems, as tooling in your daily jobs, or simply as dependencies of our hobby projects. Open source software is an important building block of our everyday life. As an example, in the 2020 State of the October's by GitHub, which further highlights the importance of the open source software supply chain. Most companies on GitHub actually rely on some form of open source software in their stack, which results in a widespread usage. And the median number of dependencies in the NPM ecosystem is 683, resulting in a large potential attack surface. I used my extensive art skills to better underline this fact. So this is the software supply chain of your project. This is a malicious attacker compromising on one of your packages. And this is your whole software being compromised and your project collapsing. As the recent protest drama showed, even well-meaning actions can result in a loss of trust for the software supply chain. Just as a refresher, as a show of political support, maintainers introduced bad faith code, mostly targeting Russian citizens into their packages, which eroded overall the trust in the software supply chain. So for our work, we wanted to investigate how open source projects handle security and trust behind the scenes, specifically processes that are not directly visible from the code base. And we based our investigation on the following research questions. First, how are open source projects structured behind the scenes? Second, if and what guidances and policies are provided by open source projects? And third, how do open source projects approach security and trust challenges? So with some more or less recent drama about research approaches in open source, we of course asked ourselves how we could conduct this investigation. And after a long and hard thinking process, we arrived at the following approach. We will just ask them. So for this, we of course needed some projects. And we decided that for recruitment, we first wanted to mostly focus on a diverse sample of projects so that we can cover a wider range of structures and processes. And as such, we recruited from multiple channels, including a certified sample from GitHub, personal connections, famous projects, and further recommendations by our participants. The full recruitment process is described on the website, in the paper, and in a provided supplementary paper as well. Generally, we reached out to potential projects via public email addresses they listed or via the public email addresses of their maintainers. This approach is, of course, somewhat difficult as we compete with a lot of spam that these people get to the public email addresses. So to highlight our approach or how we try to circumvent that, I will quickly go over one of our email templates that we sent. So overall, we highly customized our messages, so we only sent in total very few emails. just so that we really could customize the emails for the specific people or projects we are addressing. So this already gave us like a head start above most of the spam messages. We also started off with a quick intro of what we are doing, what we are planning, just so to get the attention of the potential participants. We gave a short pitch of our research, tried to alleviate their concerns, and highlighted possible benefits. And most importantly, we provided a landing page with further information, just so that, I mean, open source developers are online a lot, right? So, and they probably lead a lot of text online on websites. So we just provided a landing page with like all the information, all the data handling information, all the consent and stuff and so on. And made it easily shareable, which actually resulted in additional recruitments because people shared this website then with their colleagues or friends. And lastly, in our email template, we apologized for cold emailing them. We highlighted why we thought this approach was necessary to reach a diverse sample. And we ensured them that they did not have to opt out in any way for further emails. That this will be our only email. We also, in addition to personalized emails, we advertise directly to specific communities by joining their, for example, Slack channel or Mattermost channels or Discords. And after asking moderators there for permission, we posted an advertisement for our study. Some of the moderators were kind of surprised by this. So apparently that's not a very common research venue. And while they allowed us to post our study, some also decided to update the rules for the future. So if you encounter this during any of your future studies, I'm deeply sorry for ruining this research venue now. All right, now we had our participants. We decided to, or let's move on to the results. So in total, we conducted interviews with 27 participants. For this graphic, I roughly sorted our participants by their highest project role. And we found that they tend towards the leader or owner side. We suspect that this might be an effect of us just being further referred up the chain. So if we contacted a person that was not necessarily like the owner of the project, they often arranged for us to like at least contact or meet the leader of the project, get more information there. Overall, we covered these 8 areas in our interviews. For this talk, I will quickly go over the 4 more technical categories. For an in-depth look of the like more structural categories, I have to refer you to the paper. So let's get started with security challenges. We asked our participants if they encountered security incidents in the past, and the majority did not. Encountered past security challenges that not necessarily led to an incident included suspicious or low quality commits and vulnerabilities introduced by dependencies. Overall, some of our participants mentioned that they could easily spot malicious code commits on GitHub. Next, we were interested in guidance and policies provided by the projects. The most mentioned type of guidance by our participants included general guidance for contributing to the project, programming language-specific guidance such as code styling or security advisories on certain functions, and guidance for project setup and build infrastructure. A factor for not providing guidance included the required program hours, such as in this example. Next up, we were interested in the trust process behind the scenes. We asked our participants if their projects had encountered a trust incident, by their own definition, in the past. And a large majority of the projects had not. Mentioned trust incidents included drive-by cryptocurrency minor commits, failed background checks for repositories that are like based on a company, so where the company actually hires people, and proactive account block after a stolen laptop of one of the maintainers. Lastly, we were interested in the opinions and suggested improvements for the status quo of our participants' projects. We roughly sorted the suggested improvements of their projects in categories, with the majority requiring more person hours, followed by more monetary funds and switching the project to a completely different infrastructure. Yes, this included Rust a few times. Here are some examples of suggested improvements, which included rewriting the entire stack, rewriting every pull request, review every pull request for security, and invest into automatic tools for vulnerability findings. To summarize our findings, we found that projects are highly diverse, both in deployed security measures, trust processes, and motivations. That a growing scope and contributors results in growing needs for security and trust processes. and that smaller projects handle security and trust incidents as they happen. So they often haven't like processes in place or have thought about certain stuff. And but for them it's fine. They decide they just handle them as they appear. To recap the whole thing, open source code appears as foundation, glue, or during the build process in many software projects. Thus, by providing open source developers with support and enabling them to write secure software, all dependent software also benefits. And as researchers, we advocate against treating open source developers solely as data sources and review process black box focusses, and instead to consider them as valuable partners in bringing security and trust to open source software and software ecosystems as a whole. We argue for supporting open source projects in ways that better consider individual strengths and limitations, especially in the case of smaller projects. That was our talk, Committed to Trust. Thanks for listening to my talk. Any questions?
Thank you so much for the talk. Oh, you're right there. All right, yep. You get to ask your question first.
All right, thanks for the great talk. I noticed some similarities between this work and how people introduce vulnerabilities by looking at Stack Overflow. Can we take lessons from all the research that's been done on that and apply it to here? Do you think it's relevant?
I would say that's a great question. I would say in some way yes, in some ways not, just because like I feel it for open source projects, like one of the biggest struggles is to attract contributors, right? And if you like just move all the same application or all the same defenses and approaches and so on over, I feel like they probably will lose maintainers or not attract as many. So I guess my answer to that would be depends. Sorry for the shitty answer, but like most open source projects like are in a like very tight balance between attracting maintainers and providing like many security checks and tests and so on.
So if you're basically a small project maintainer, but one of the ones, you know, that in the supply chain is like where it falls, everything falls down, like in your picture. After reading your paper, what would you say they should do in order to like be less vulnerable?
Mm-hmm. So of course, they probably can't employ all the approaches and processes that large projects can because they simply don't have the person powers. My suggestion would be but still look at what the big projects are doing. So for example, Red Hat and OpenFSS and so on, they have some guidance for smaller projects. They probably can't apply all of that simply because they're too small and they don't have the person power. But they can look at it and like cherry pick the stuff that works for them now. And then if they grow larger in scope, they can apply further processes and approaches from there.
Thank you so much. Doesn't look like we have more questions. So thank you once more for the talk.